Hey there, science fans! Have you ever seen a rusty old car or a crumbling bridge? That's corrosion in action, and it's a big problem. Corrosion happens when a material, like metal, breaks down because of reactions with its environment. Think of it like a slow, steady attack that weakens the metal over time. For corrosion to happen, we need three main ingredients: a metal, like iron, water, even just a little bit of moisture in the air, and oxygen. When these three get together, they set the stage for a chemical reaction that can cause some serious damage. Corrosion is a major headache for all sorts of things made of metal, especially steel. It weakens structures, leads to costly repairs, and can even cause dangerous accidents. That's why we need to find ways to fight back against corrosion and protect our metal stuff. So how do we stop corrosion in its tracks? One clever way is with cathodic protection. It's like giving metal a superhero shield that prevents it from rusting away. Cathodic protection works by changing the way electricity flows in a metal. Remember those three ingredients for corrosion? Well, it turns out that the reaction between metal, water, and oxygen involves the movement of tiny electrical charges called electrons. Cathodic protection stops corrosion by providing electrons to the metal we want to protect. It's like giving the metal a constant supply of negative charges, which counteracts the corrosion process and keeps the metal safe from rust. Pretty neat, huh? There are two main ways we can use cathodic protection to fight corrosion: sacrificial anodes and impressed current. Both methods involve using a second metal that's even more likely to give up electrons than the metal we want to protect. In the sacrificial anode method, we connect a more active metal, like zinc or magnesium, to the metal we want to protect. Since the sacrificial anode is more likely to corrode, it gives up its electrons to protect the other metal. It's like a selfless hero sacrificing itself to save the day. The other method, impressed current, uses an external power source to provide the electrons needed to protect the metal. This method is like having a superhero team constantly supplying the metal with a protective force field against corrosion. Each method has its own pros and cons. Sacrificial anodes are simpler to install and don't need any external power, but they need to be replaced regularly as they corrode. Impressed current systems are more complex and require a power source, but they offer more precise control and can protect larger structures. While cathodic protection is a powerful tool in the fight against corrosion, it's not a perfect solution. It can be expensive to install and maintain, and it doesn't work as well on large, uncoated surfaces. Plus, even with cathodic protection, some corrosion can still occur over time. That's why it's important to remember that cathodic protection is most effective when combined with other corrosion prevention methods. Things like using corrosion-resistant materials, applying protective coatings, and controlling the environment can all help to extend the life of metal structures. So, there you have it. Cathodic protection is a fascinating and important technology that helps us protect our infrastructure, vehicles, and other valuable metal objects from the ravages of corrosion. By understanding how it works and using it in conjunction with other methods, we can keep our world running smoothly and safely for years to come.